This is our second week of the lecture for CSE 455 Software Engineering, 13th of April. Um, like to um, remind you to access Slack. It's been set up for all the teams, and I have announcements in that communication system. That would be our method of communicating, and please take advantage of that. I'm also reminding you to sign your NDA and the course agreement. These are two different documents. Um, the course agreement is part of the syllabus. So go to the last page of the syllabus, sign it, and send it to the link specified by Ben. Okay. All right. Let's proceed. Let me remind you of where we are in the course syllabus, and um, here it is. Let me download that. Um, we are here at the second week of our class, and for this particular week, we're talking about project organization and communication, which we have done already, but we have to define what are the different activities we're going to do in our project organization. As you have seen in Slack, we are now a virtual software company, or a mock software company, called CSE 455 Inc. And of course, the CEO of the company is yours truly. So we're gonna play roles in this software company in learning software engineering. And chapter 4 is about requirements elicitation. You should be contacting your clients, asking about functionalities, additional or improvements. And I believe all of the software projects we're doing this spring are continuation from previous. It's a good example of the software lifecycle, that the software never ends. It has a life of its own, that after you implement it, there will be maintenance because of changing requirements or changing environments along the way. So in this particular case, we are continuing the project which was begun either last spring or previously. Okay. Um, um, for your activities in the lab, you're supposed to meet 10 to 12 virtually using Slack. So I want to see activities going on in the lab through Slack. Communicate within your team, or to other teams, or to your TAs. And I want the project managers and assistant project managers to submit to me an absence report. The absence report is simply who are absent in the team, and and also for the QA team lead to report to me who are absent. And absent means they didn't participate in your session from 10 to 12, for those who are in the Monday group, and also for those in the Wednesday group. So that will be a simple attendance to be um, communicated to me via Slack, of who are absent, or who didn't participate in your team meeting. Okay. All right. So let me proceed to the next part of the syllabus or the lecture today, um, you have seen this poster, and this particular poster has the life cycle that we're going to follow from an idea of a software product by the client. The first phase of the software lifecycle we are following is the software requirement specification. Remember, the client talks to the development team. They develop the the uh, functions that were specified by the client. QA team tests it, and when the QA team has successfully tested the prototype, gives it to the client for feedback or any kind of comments or suggestions. And this is very important because if you lose connection with your client, you may be developing your software uh, which the client doesn't like. So you're wasting your effort in producing it. So we want our effort to be directed towards completing what is required. And also, we do this in several iterations. It's in incremental step. That's the agile software development, where software is developed in incremental steps, and each increment is a prototype closer to the fulfillment of the idea of the client. So the first document is called SRS, Software Requirement Specification. And the software process we will apply to the SRS is a format suggested by the IEEE standard for writing software requirement specification. So we will follow that software process instead of ad hoc format of the document. And also like to draw your attention to the different role playing you will be um, undertaking in this virtual software company. Uh, yeah, there is a project manager, there is an assistant project manager, and there are software engineers as members of the team. For the QA team, there is a team lead, and there are QA engineers as members of the team. You are playing that role, and hopefully, through the playing of the role, you learn what is software engineering. Okay? All right, let's move on. Uh, let's talk about project organization and communication. So let's do that. Um, let me about the delay in my lecture. I'm continuing here on the project organization and communication. Let's go to chapter 3, which is uh, the discussion about activities in the project organization. What you see here is a model of a project expressed in UML class diagram. If you notice that this symbol is representing aggregate. That means the class project consists of four parts, and the parts are the work product, the schedule, what are the tasks to be done, and who are the participants. The participants, of course, are all of you, and each one of you has a role to play, whether you're in the management level, project manager, assistant project manager, or team leads, um, or you are team members, you are software engineers or QA engineers, you are the participant of the project. The schedule is a timeline of when things are going to happen. We cannot just say, okay, we're going to um, just meet by the finals and show me your work. Can't have a free schedule of things that are going to happen. There must be a plan on what are the what they call it milestones that needs to be reached to achieve the final goal. There are two milestones here in our software development. By the seventh week, you should be producing the first prototype of the software project, and the second prototype will be produced on the final. So we have two iterations following the agile software development. So what are the things that we are supposed to do before the seventh week or the finals week? And these are the tasks that are defined of what are the things to achieve uh, for that given schedule. And the work product is the definition of the kind of work that you are producing, whether it is source code, it is a document, or it is a modeling diagram that defines the work product. It's a tangible output of your work as fulfilling a particular task. And the tasks are measured in terms of the schedule, whether you are achieving the deadline or not, and the participants are you guys. In a team organization um, assigned to a particular software project. Okay? Now, here in this diagram, you'll see here that the entire organization, and our organization, as I said, is CSE 455 Inc. So think of it not as a class, but a software company where you guys have been newly hired. So you guys are freshly graduate from computer science, and you are hired as either software engineers or QA engineers. And so inside the organization consists of several teams, and each team is assigned a particular task or a mission. And for our case, each team is responsible for developing a specific um, project, a software project that is required by a real client wanting this project to be done. And within each team, it consists of you. You are the software engineers and QA engineers that are hired by this company to actually carry out the software project. And that's in terms of UML class diagram, that's how you represent our class, CSE 455. Okay? Here is an example of a simple project organization. So this is one possible organization for a software company. So that could be a team whose responsibility is management. So they plan, they design probably, and the different parts of the project is divided into the user interface, the database team, and the control team. So in this project organization, there are several projects that the organization accepts, and this particular team organization provides the management, the user interface, the database team, and control team. So a particular team is not assigned to a specific project, but everybody contributes to the project accepted by the organization. Um, this was the organization I had when we are only doing one big project at a time. Um, the project is called Algorithma, Algorithm Animation. So that's one big project that we are doing in the class, and the class is divided into these separate teams with a specific function, a specific task to do. In our current situation, each team is a complete uh, team consisting of management, UI people, database people, control people, all in one particular team, and you are responsible for a single project. Mobile app is such a project um, that can be relegated to a specific team. It depends on the complexity of of the um, the project, and I have read in an article that Zoom, the famous online uh, project or app that is very popular now because of the online online needs of universities, are written by 500 Chinese software engineers. So you can just imagine that single product called Zoom are divided among these specific teams. So that mobile app is such a big project that it needs to be compartmentalized through different specialized team. Okay? All right. And the management team, as you see here, following the previous project organization, the management team provides the leadership and the management of the different teams, the user interface team, the database team, and the control team. And um, this link here in UML diagram is the communication about decisions made by the management team, and the different teams respond through the status of the decision. So in this uh, project organization, the management team is centralized into a single team, whereas in our case, it's kind of a distributed team where each team is autonomous to make decisions uh, with regards to the mobile app. But as I said, it all depends on the project you're doing. Zoom is such a big application that it needs probably this kind of organization to carry out the different big parts of the software. All right. Um, Here in this particular diagram, this is called an object, UML object diagram. So object diagram, the difference between a class diagram and object diagram is this one. You see here, the class diagram talks about each particular class diagram as um, the definition, just like in data structures, you define the, uh, the data structures in terms of generic terms, like this. And in the object diagram, you now have a specific name of the different objects. So right here, we are defining specifically what is a user interface team. So a developer called Alice is the team lead. So this user interface team here consists of uh, uh, 5 members of the team. Alice is the team lead, although her designation is developer. John is an API engineer, and as you know, APIs are very important in today's software development. We don't develop software from scratch. You look for APIs that you can reuse and apply it to the project. We don't want to re-implement what was done already. So these APIs help save time in development, but the need is for the API engineer to understand the API and know what it does and what it can be useful in the project, and also to probably modify or edit the API to conform to what you need. All right. Mary is a developer too, but her task is a document liaison. Now, documentation has been kind of frowned by software developers because it may not involve software coding. But documentation is one of the most important part of the software project to maintain the software long after it has been developed. Like what you are doing now, you are inheriting a previous team software project, and if only if the only artifact you are inheriting is the source code, then you are in for a very hard time to understand what is the software all about. Imagine reading let us say, a 15 to 20,000 lines of code without any documentation at all. Reading 15 to 20,000 lines of code is daunting. That is hard to understand. You guys probably have experienced writing source code last week, and then when you read your code that you guys have written yourself, sometimes you scratch your head and say, what the heck did I write this for? So imagine this source code is being given to another software engineer who has to read your code. If there is no documentation, heaven help you to understand what is the source code telling you. So documentation consists of software requirement specification, which tells you what the software is supposed to do, and the software design, which is a class diagram or UML diagram of what is the graphical representation of the organization of the software. And of course, having comments on the source code also help. So the combination of the software requirement spec, the software architecture and design, and also I am also requiring maintenance manual, which is like a post-mortem report of the previous team about what they did to the software, uh, including commented source code, will help you continue to the project. So if the scenario I gave you that you only inherit source code, um, I pity you for spending a lot of time understanding what the source code is talking about. Now, here are the other two members of the team. Chris is a developer, and Sam is a developer. And here is um, the association of Alice to the management team, John to the architecture team, Mary to the documentation team, and Chris to the testing team. So in this simple diagram, you can actually see what are the interfaces or communication structure occurring in your project organization. Okay? All right. Here is another diagram defining the roles of every um, member of the software company. Uh, the role is um, the the root of all of these other classes. So this is the superclass called role, and the roles. Remember this diagram here. It means its inheritance. And so there are different kinds of roles that you can play inside a software company. You could be a developer. I like to call you software engineers or QA engineers rather than developer or programmer because of the title software engineer carries with it the experience of being able to understand the software process. And programmers are kind of low level um, experience for me because a Java programmer or a PHP programmer may not know the intricacies of software design and the best way to implement an algorithm. Okay, liaison, the manager, and consultant. So here are the uh, generalization of liaison to an API engineer, to a document editor, configuration manager, and the tester. The configuration manager, if you don't understand that particular class, configuration manager has to do with repositories, GitHub and Bucket, um, Bitbucket are your repositories, and you must keep different versions of your source code in the right structure, or else you lose uh, the um, uh, the original history or the history of the development of that software. The manager could be a project manager or a team lead, and we have both in our virtual software company. The consultant could be the application domain specialist, the solution domain specialist, or it could be the client, or it could be the end user. So in our software company, we have the TAs sometimes fulfilling the role of the application domain or solution domain specialist. And the client could also be both, like the project Breath of the Coyote. The client is Daniel Mayer. He was the project manager for Breath of the Coyote in software design 440, and uh, and so he has detailed information about about the mobile game. He is also the client for that particular project. Okay, all right. Now let's talk about the different roles of the system architect. The system architect and the object designer are separate role, and the system architect is actually the highest paid personnel in a software company because that particular role is ensuring the consistency of the design decisions and interface style. And as I have told you, the system architect is the one that creates the blueprint of your entire software. Just like in building architecture, the architect designs the overall structure um, of the building and the different function the building should have. The system architect is the one that creates the system design in terms of UML diagrams of what the software is supposed to do. And the object designer is the interface definition of the assigned system. So uh, the object designer deals with actual data or actual uh, information about the different design architecture. So the design architecture, it defines um, the abstract or the ideal system to be built, while the object designer deals with the specific function or specific data that is going to be used in the implementation. So architect is the overall design, object designer is the uh, actual implementation of the design you, based on specific data. So the object designer is also very important, but maybe second in importance to system architect. The implementer is the software engineer or the programmer um, or developer that is implementing the code of the class or of the object designer, and the tester, which is a QA, which is, as I have said in a previous lecture, this is usually the entry position in a software company. You begin as a, a tester in a software company when you join it. Okay, all right. Now we talk about package diagram in the previous chapter. So here you see the work products that is being produced in a database subsystem. So you see this diagram as a package, and what it is a high-level definition of a particular unit or object, and inside it is the definition of what this package consists of. So you see here in the inside the package are object diagrams. So the definition of the package consists of 1, 2, 3, 4, 5, 6 kinds of objects. So the persistent objects is the class model, the design objects, the test plan, and these two are models. These are documents, the test plan, the testing defects, and the inspection defects. And here is the source code. So the source code is being inspected and tested according to a particular test plan. So that's the definition of a package diagram in terms of what is inside its detail. So you may design a system using package and then delay the detail of this package to a later step when you have defined it more clearly. And here are the different definition of the work product. So we talk about work product, and so we must produce persistent objects, design objects, we must produce subsystems, test plan, testing defects, and inspection defects. So the work product defines the output of each particular team in terms of their progress toward the uh, implementation or development of their software, and the kind of persistent objects that we are talking about here is for persistent objects, it is class model for design objects. Subsystem is in terms of source code, and the last three are documents. So these are output by a team towards the development of the software. So that defines work products. So you, as a team, should define your work products. What are the output of your team in terms of work products? And in what form the work product could be? It could be document, it could be source code, or it could be a UML diagram as the work product. Okay, so unit of work is defined to be the different tasks and activities that you are doing, and that is the inheritance here. Unit of work is a specific class of unit of work, and the task, of course, depends on your role. And the unit of work also communicates or send results to the work product, and the work package actually describes in the unit of work. So unit of work is central to every team. As a matter of fact, your output should be defined in terms of unit of work. What are the unit of work that you are supposed to do in order to say, I have done this particular phase of the software development? So you define activities, tasks that you need to do, and the output of your unit of work will be contributing to the work product, and the work package is being described of what is that unit of work. Okay? All right. This last table is the schedule. An important output of uh, the, the activities of a team is how you're going to schedule your your activities. So here is an example of a task realization of a database system. So the requirements elicitation is going to be responsibility of the system architect. It elicits requirements from the subsystem about different things: storage, persistent objects, attributes, and relationships. And the output is a database subsystem, design, API, persistent objects, and UML class diagram. The object designer is responsible for the database subsystem design. So designs the database subsystem, including possible selection of a commercial product. So input is a subsystem API, database subsystem design in UML diagram. So they work in close cooperation for the system architect and the object designer. Then the database system implementer, the developer, implements the system, produce a subsystem design, and produces source code. The database subsystem inspector is also an implementer, a tester, or an object designer, conducts a code inspection, and the input is a source code and produce a list of defects. The tester, or the QA, guys, develops a test suite. The input to that activity is the subsystem API, subsystem source code, and they produce a test and test plan. And then finally, the database subsystem tests. First they plan, then they implement and executes the subsystem test plan, producing test results and list of defects. Now, this table is very nicely implemented or shown as a Gantt chart. So I want you to study Gantt chart. And Gantt chart is a graphical representation of your activities. Now look here, these are the task name, and it says 5 days, 15 days, 2 days, and so on. And let's say you start your project, your calendar date here is November, and you started on the 13th of November, and that task, that 5 days of storage subsystem requirements elicitation is takes you to the 19th of November to finish. Afterwards, the subsystem design begins, and that takes you also 5 days, finishing on the 25th of November. Okay, 19th to the 25th. And then the next task, storage subsystem implementation, takes you 15 days. So it goes all the way to December 16. And then in parallel, you can also do the storage subsystem test plan, and takes that and it takes 10 days. By the way, there is 2 days needed for storage subsystem inspection, where they will be joined with the last activity of storage subsystem testing, 5 days. So I want you to have a schedule using Gantt chart in your document called Software Project Management Plan, specifying or showing the different tasks to be done in specific month days. Okay? All right. So that ends the specific chapter on project organization and communication. Let's look at this document called the Software Requirements Specification. In this particular diagram. Let me get back to that again. You have the um, diagram that I have showed you earlier about the software lifecycle that we are following. So from your client with an idea of what to do for this cycle of development, remember, I think all of you are continuing previous projects. The idea is what other things they want you to implement to improve or add more features to the software that they want you to work on. So the first document is called the software requirement specification. So following this software lifecycle, the first phase is defining what are the functions that you want to improve or add to this specific cycle of the software. Okay, so let's look at the document that we're going to use, and this is the software requirement specification. And if you download it from the mobile app dev, you will see the IEEE standard for recommended practice, IEEE recommended practice for software requirement spec. So this is what I call the software process of how to write the software requirements specification. Of course, before you start writing this document, you should have talk or interview your client and talk about the the different needs that the client wants to implement for this cycle. Now, the software requirement specification is consists of uh, three sections. First, the introduction, then the overall description, then the specific requirements. Usually, specific requirements are the user interface design uh, that you will develop. So, for the introduction, the purpose of this document is what is it that you are doing this time. I would like you to include in the purpose of that this is a continuing development and put the information of who was the last developer and what they have accomplished and what you want to accomplish this time in a very brief um, discussion in the purpose. The scope is the limitations of this specific um, uh, development. And so you will say the software will be able to do this, but it won't be able to do that. So the scope defines what is the limit of this implementation. Definitions and acronyms and abbreviation. Um, the purpose of this section um, is to avoid the misdefinition or the wrong interpretation of a term. As you know, in computer science, we use a lot of acronyms and any abbreviations you want to spell out. And also for the client, they may have terms and definitions that you may not be familiar with, and so you want to define that here in this document. So both of you, the software engineer and the client, list all the definitions, acronyms, and abbreviations that is subject to misinterpretation. References are the list of documents that you use in writing this software requirement specification. So this includes uh, previous SRS that you have used for writing this SRS, and other uh, information or references that you have used. Like, for instance, you may refer to the IEEE standard, which you use as the format of this documentation. Overview is a summary of the following sections that the reader will find in your document. So you may say the overall description will contain the use case diagram and deployment diagram of the software, and the section 3 specific requirements will contain mainly the user interface and specific function of what the software will do. All right. So let's look at the first section here, the system interface. The system interface is usually a UML deployment diagram, and that is defining the different systems, hardware and software that you will need to um, run the software. And so, if you remember in last week, I showed you examples of deployment diagrams, and this defines all the systems that will be needed to run your software. The user interface here just lists the the different UI that you will need. Uh, the UI design will not be here. Remember that the UI design will not be found in this section. That UI design will be found in the next section called specific requirements. What you will have here in the user interface are just the list of the names of these interfaces, and what are they um, going to provide for the user. So just the list of the user interfaces, no design of the screen. The UI design will be in section 3, specific requirements. Okay? The software interfaces are the different software that you will be needing to actually implement the software. So this could be Objective C uh, the iOS, if you are actually developing Apple mobile app. So these are the software interfaces there. The communication interfaces refers to the different protocol, HTTP, HTTPS, communication protocol that you will be using. Memory, I would like you to specify limitations of the memory that you will need. So use the lowest common denominator of the mobile device that you will support. Of course, older version will have a lower um, specification, but those will be um, defined here. What's the lowest memory need that you can support based on the device that you will use? Operation here refers to your operation of the mobile app. Will this be a 24 by 7 operation throughout the year? Or there will be a period in a year that it is going to be out of use because of maintenance. So is there a period in a year where it will be unavailable for use because of maintenance. The site adaptation requirements, usually this refers to requirements of a company or a enterprise that may need a room for their servers and other computers that will be needed to support the operation of this function. And usually there is none here because the most common application now runs in the cloud. So there is no physical need for servers and other things. Uh, Section 2.2 is the product function. So here you will have the use case diagram. Remember use case diagram? That defines the different functions of this particular um, um, product. And these are new use case diagram that you are adding. You may want to show the previous one, uh, but you distinguish the new use case diagram or use case diagram that you will improve in this specific iteration. So use case diagram are the different use case, and if there are new use case that you will add, then make sure you differentiate those new use case diagram from the previous ones. But this is the diagram, UML diagram that we use to actually specify the function of the software. The user characteristics are in the use case diagram. Remember, you have actors who are the users of this system. So define the characteristics of that use case. So for instance, if it is a student and the student is a student in computer science, then we will assume a certain computer um, uh, ability or computer savvy of the users. But if it is a student, let us say, in liberal arts, then you may assume less computer savvy of the user. So you describe it here. Constraints are any kind of restriction that you are having in the constraint. So things like um, that you have to um, satisfy people with disabilities that you are not going to implement by this time, but later on you will. So that will be a constraint in your specification. And any other assumptions and dependencies that you may have. So assumptions like there will be certain number of users at any one time that the mobile app or the software will be in use, and you are not considering thousands of users at this time to use your software. So if that is the case, then you have a problem of traffic or congestion of the request for service for this specific software. Okay. Now the specific requirements, as I said, is a uh, is the specific interface requirements. So specific requirements talks about the user interface. So the user interfaces that you have defined, remember, you define this in the section 2, but what you have in there is just the list or names of those user interface. So you refer um, them here in your section 3, and what you have over there is the definition. So you may repeat the same definition here of what it is, and any hardware interface that you might need. It could be a certain um, uh, RGB or HDMI plug that you will need, or USB that will be specified here. Any software interfaces that you will need to implement the user interface, what kind of user interface that you are using to define it, and any communication. This refers to the internet access if you need one. Okay. Now here is the functional requirements. So for a specific user interface over here, you talk about mode 1. So mode 1 for this user, what are the different user? You define the functional requirements for a specific user in your use case diagram and define the functional requirements. So the drawing of the user interface are done in here. So for different modes, and the mode are for the different users of your use case diagram, you define the different functional requirements that this user need. So mode refers to the specific user in your use case diagram. So let us say it is the library system that you are designing. So this could be the professor mode, this could be the student mode, and this could be the mode of the browser. We just want to browse the system. And for each functional requirement, you define, you draw the user interface. Okay? Now, performance requirements, what are the performance requirements? And this usually refer to the length of time the user has to wait before the system is ready for your next uh, use. So this could be defined in terms of seconds, that the user should not wait more than 3 seconds or 2 seconds to see the cursor coming back and waiting for the next command. So these performance requirements is a part of the section 3. Are there any design constraints? So are you limited to just object-oriented approach in the design constraints, or you are not? And so the design constraints define whether this would be implemented in the like for instance in the system level rather than a high level language constraint. The software system attributes, are there any system attributes that you are looking for? This refers to the different APIs that you will be using. If you are thinking of using those APIs, what attributes of the API software system that you are looking for. And the other requirements, we will talk more about this, are any non-functional requirements that the software will need. And this talks about reliability, usability, and many other non-functional requirements that the system will need. Okay, so that would be a quick introduction to the SRS. Next meeting, I'm going to show you the different samples of the SRS that is in our mobile app development website, so you can see how the definition of the SRS is implemented in actual document. Okay, see you and be safe and healthy.